Good afternoon, everyone. Welcome to the 14th talk of the online seminars in psycholinguistics. I am Maya Mota, and with Dr. Pamela Toas, I would like to thank you all for being with us today. These seminars are organized by the Language and Cognitive Processes Laboratory, coordinated by me and affiliated with the Graduate Program in English and the Graduate Program in Linguistics at the Federal University of Santa Catarina, and by Plibimult, the Bilingual and Multilingual Language Processing Research Group, coordinated by Dr. Pamela Toassi and affiliated with the Graduate Program in Translation Studies at the Federal University of Ceará. Today, we have the honor to welcome Professor Dr. Denis Drieghe from the University of Southampton in the UK. And to introduce him, I will invite dear Professor Dr. Bernard Engele. Before handing over to Bern, I'd like to thank you, Professor Denis Drieghe, for accepting the invitation to talk to us today. Bern, over to you.
Okay, thank you very much. Yes, good afternoon to you all. I'm very happy to be back here this time to introduce the speaker. And I am extra happy that the speaker is Denis. I've known Denis for a long time now, more than 10 years now. Because he's always been sort of in a very closely related area to my own. So Denis has been at the University of Southampton now for 11 years. So he joined the psychology department in 2009. He is an associate professor in experimental psychology now. And what he does in his research is recording eye movements to examine cognitive processing during reading. So, which is the same thing that I do, essentially. Denis's path to this has been a little bit different from mine. So Denis didn't actually leave his home country of Belgium, at least formally, until after his PhD. So Denis got his PhD in experimental psychology so he got that with Mark Brisbert at Ghent University, where he also got his undergraduate degrees. So what was called licentiate at the time. I hope I pronounced that correctly. Then he was a postdoctoral research fellow at the Fund of Scientific Research Flanders for 5 years, and that is an amazing grant, or an amazing position, because it enabled him to travel all over, be really, really independent. So he spent a lot of time at the University of Massachusetts in Amherst in the US, where he spent quite a long time working with Keith Rayner, who was my PhD supervisor, and Sandy Polacek. And he also was a visiting research fellow at the University of Southampton, where he worked with Simon Liversidge before he then finally took on a lectureship in 2010. So throughout this time, I mean, Denis and I have met a lot of times. He's just up the road from Bournemouth. It's always been a pleasure talking to him, and we've spent some really fun trips to China together. Those were always highlights. So he's just a really great person to have around. So Denis is now an associate editor for Behavior Research Methods and Psychologica Belgica, and he has received grants from the Fund of Scientific Research for Scientific Research Flanders, but also the Leverhulme Trust, the Experimental Psychology Society, and the Australian Research Council. So it is my pleasure to welcome Denis, or Professor Drieghe, because I would like to say his last name, to this talk series. And yes, Denis, you can go ahead.
All right, thanks, Bernie. Thank you for that nice introduction. It's true, Bernie and I go back very, very long time. We even lived in the same house for a while, but not at the same time, in Amherst, Massachusetts. I think Bernie was on an exchange while he was still a student, and I was also a PhD student at the time, so it goes back really long time. Okay, thank you for that introduction. Let me just share my slides here. Okay, can everybody see my slides? Yep. Okay, brilliant. So today I'm going to be talking about findings we did with a corpus called the GECO corpus. And the GECO stands for the Ghent Eye-tracking COrpus of Mono and Bilinguals reading an entire novel. Now, when Pamela asked me to give one of these recorded sessions, the first thing I wondered is, like, what would I talk about? So she said, like, you can talk about one of the top, of course, psycholinguistics, one of the topics that you're active in. And then I thought, wait a minute, I know that there will be people in the room who came to my previous talks when I was in Brazil, so we'll choose another topic. And so the first time it was in Fortaleza, and it was, I'm still working there with Elise Teixeira. And I gave a workshop there early January in 2019 on statistical programming in R and linear mixed models. And whilst I was there, I also gave a talk on my work on word skipping. And then a year later, earlier this year, actually this was my last trip before the pandemic, so it's the last time I was on a plane. I gave a talk about reading online. So I thought, like, well, I can't do those topics, and I was thinking to myself, what would people be interested there? And then I thought, like, I looked at the schedule and stuff like that, and I thought that there was probably quite a bit of people interested in bilingualism. And so I supervised one PhD on bilingualism, and this is the student here, Ushi Kop. Now, she graduated a couple of years ago, and then in the meantime, we were able to publish all the findings. The project in itself is finished. Ushi, in the meantime, is no longer in academia. She actually became a poet, and now she's known in Belgium as a poet. And what I'll be talking about today is the work she did on bilingualism in collaboration with me, and the work was done at Ghent University whilst I was already at the University of Southampton. Okay, these are all my collaborators, Wouter Duik, Nicolas Dieriks, Ushi Kop, she did most of the work, Emmanuel Keulers, and then myself, and the other 5 people are all at Ghent University. Okay, so let's talk first a little bit about the importance of this research, the importance of bilingual research. I'm giving this talk in Brazil. I'm pretty sure that most people, when I say this, will start nodding and they will go like, oh yeah, that's true. First of all, let's define what a bilingual is. Now, Grosjean 92 is one of those classic definitions that you see quite often. And he said, bilinguals are those people who need and use 2 or more languages in their everyday lives. And actually, more than 50% of the world population meets that criterion, that they are bilingual or multilingual. Now, a lot of people who are not in psycholinguistics, when they say bilinguals, they usually refer to what we call balanced bilinguals. In other words, people who have equal proficiency in both languages, which is quite rare, but that's not the definition of a bilingual, that's the definition of a balanced bilingual. A bilingual is just somebody who uses 2 or more languages in everyday lives. I'm assuming that there might be one exception or so, but everybody I'm speaking to here is a bilingual, because most people here will not have English as their native language. So most people here will definitely hit the criterion of bilingual. And the majority of the world is bilingual. However, when you look at psycholinguistics, you'll see that most theories of visual word recognition, and indeed reading, and that's the bit I'm interested in, reading, are tailored towards a monolingual person. And that goes for most models. Now, we know that the majority of people are actually bilingual or multilingual. And we also know, as you will see in the next couple of slides, that it has quite a profound impact on how your mental lexicon is organized, whether or not you speak 1 or 2 languages. So this clearly shows the need for behavioral research and adjusting our theories to bilingual readers, given the fact that the monolingual reader is actually the exception. Okay, so early work in this field of bilingualism and reading was exclusively within the field of visual word recognition. I'm talking here about the psycholinguistic side. I know that other stuff is happening in linguistics and so on. But early days, psycholinguistic research, like when I started going to conferences, if there was a session on bilingualism, it was quite often to do with this question, which is, how are the two languages organized in terms of lexicon? Are there two separate lexicons, or is there one integrated lexicon that contains the words of all the languages you speak? And intuitively, people will often think of it as two separate lexicons, based also by the intuition that you are typically able to use one language without making too much errors, without making too many intrusions of the other language. So people thought like, oh, maybe it's like an on and off switch. Early days, it's like an on and off switch. You focus on one lexicon and then the other lexicon is not active. Especially if you are in like a setting where you're only exposed to one of the two languages, you're able to ignore the other one quite well. But then we saw actually a flurry of experimental materials showing up, indicating that it's actually quite unlikely that that's the case. What we found were so-called crosslingual lexical interactions. And this is when a lexical entry in one language starts influencing how you process a lexical entry in another language. And for this, we use specific kinds of words, such as, for instance, cognates. A cognate is a word that means the same in both languages, but is either written identically or written quite similarly. So here, the cognate apple or appel in Dutch is a cognate. It means the exact same thing, the same fruit. However, as you can see, it's written slightly differently. An identical cognate in Brazilian Portuguese and English, for instance, is banana, which is written the exact same, if I'm correct, in both languages. And so there's a distinction then to be made between an identical cognate and just a cognate. A cognate is when there's orthographic overlap. An identical cognate is when they are completely identically written the same way. And then we also have homographs. Homographs are words that are written the exact same but mean something else. So in this example, the word angel is in English. You know what that one means. The other word is angel in Dutch. It means it's the part of the bee or the wasp with which it stings, the angel. And so it's got a different meaning. Now, if you look at people processing language in either their first and their second language, you can see influences of these types of lexical interactions. So say, for instance, homographs. If you are, if a specific word is a homograph in your first and your second language, you will be naming them slower than control words in your second language. So somebody like me, my native language is Flemish. My second language is, well, a certain moment was French, but then it switched. Now my second language is definitely English. So my second language is English. If I have to call out loud as quickly as I can the word angel, will be a little bit slower than control words because the word angel exists in my native language as well. It also happens in the other direction. So for instance, cognates you tend to process faster. So the fact that apple looks so closely to apple in my first language compared to the second language will make sure that I will pronounce it faster in the second language. And then here's the slightly more surprising effect, also in my first language. So there is an influence of speaking a second language, even one that is acquired later, on your first language. We can pick up the fact that if I'm exposed a lot to the word apple in English, I will actually start processing the word apple in my native language faster. And for a discussion, Briesbart and Dirk did quite a bit of, did a nice review article on this. So you have all these interactions, and as a result, actually the idea of separate lexicons has been mostly abandoned, to be fair. Most people think of it now as like there's one integrated lexicon with all the lexical items from the different languages of a multilingual person. Otherwise, you'd be able to shut out those influences, but they do seem to be active, the other languages as well. It's been implemented in one computer model, which is the bilingual interactive activation model of the BIA, or the most recent version, the BIA Plus model, which is a bilingual lexicon with parallel language independent activation. In other words, they're all active at the same time. I won't be talking about that in detail. Indeed, that's also not really my level of expertise. The reason why I got involved with it, because I was always interested, first of all, in the phenomenon of bilingualism. I've done slightly more work on cross-linguistic comparison, so the comparing people reading it as a native language in different languages. However, I was in the department in Ghent University, and there's a group that does a lot of work on bilingualism, and then I was the eye movements in reading people, so of course we started collaborating on that project. Okay, so theoretically, why would bilinguals be different from monolinguals in their in how they process words, or even the same word? So imagine if you have, like, if I'm processing a specific word in my native language, to what extent does it make a difference the fact that I speak another language compared to the person who processes the same word also in native language, but they don't speak another language? What could be causing differences there? Well, first of all, one possibility is that if you have more lexical items, which you automatically will have if you speak multiple languages, you will be using them less frequently. So the idea is there, like if you have 100% of exposure and you only speak one language, then that one language will get that 100% of exposure. However, if you say you are in an environment where it's 50-50, then automatically you would assume that that 100% exposure gets separated in 50% exposures for each language. And as a result, an individual item within one of the two languages would be encountered less often than if you only speak one language. This has given rise to the idea of the weaker links hypothesis. Here is the idea that because bilinguals have about double the amount of lexical items in their lexicon, they will necessarily need to divide the frequency of use of those words between language. And as a result, compared to somebody who speaks a single language, we assume weaker links between word form and lexical representation, and as a result, slower lexical access for bilinguals, also in L1. So this is actually quite a statement. This would mean that if you speak more than one language, you will get slower in comparison to somebody who speaks only one language in your first language. So that is something we will examine in our data file today. A second reason is that why bilinguals will be different from monolinguals is you would also have the need to separate items from two languages. And this goes back to what I've already said with the cognates and the homographs. There will be interactions between entries of different languages. So there could be, for instance, interference from neighbors. Neighbors are words that are defined that, for instance, they are one letter different, or there's a letter at a different position, and they can interfere and they can make it more difficult. Or you could also find facilitation from cognates, like with the apple example, you might actually have an advantage there. So clearly there's reasons to assume that the processing might be somewhat different. Okay, now the way we will be examining this will be by using and tracking eye movements during reading. I've got 3 slides on the basics about eye movements during reading, focusing specifically on why it is interesting to look at it as a tool for psycholinguistic research. And just to make sure that if there are people in the room who are less familiar with this methodology, that they know a little bit more about it. So eye movements during reading are characterized by 2 very distinct events, being fixations and saccades. Fixations are when the eyes are still. Saccades are the eye movements you make that shift your focus to another place on the page. Now, the goal of these saccades is to bring new information into the center of the visual field. And the reason why you have to do this constantly is displayed here in the distribution of cones and rods on the retina. The red here is the distribution of cones, and what you can see here is that cones is what you need for very fine detail and color. Cones are distributed only to a very high extent in a very small specific area of the retina, being the fovea, and that this is the center of the visual field, and you have very high acuity there. When you go away from the center and go into the next region, which is called the parafovea, or even further in the periphery, you'll see a precipitous drop in the number of receptors. So you see that the number of receptors really plummets. So what you get is that your fine grain detail is removed, and instead you see that there's a lot more rods, and rods are for black and white and for movement. And the idea here is that in prehistoric days, in the sides of your corner and the periphery, it's less important to have fine grain detail, but if you got an animal coming at you, it's very important to pick up movement on the sides of your peripheral vision. So you're still very good for movement and low detail vision, but the high detail vision is in the center. Now, specifically to reading, what does this mean? We need that very high visual acuity to identify letters, because actually visually that is not a simple feat to recognize letters. So you really need to look at it. And as a result, in order to process written text, you almost have to directly look at it. And as a result, where you look is closely linked to what you're processing, because you need to process it in. And this is the beauty about eye movements in reading as a methodology, is that where you look gives us a very good indication about what you're actually processing. However, it's not perfect. Let me show you this. You see on the top here, this is a representation of the acuity we have in the visual field. So your eyes are here on this fixation point, and you see this is crystal clear, and then it really gets fuzzy when you go away from the fovea. This area here is called the parafovea. And then this is the next area. The fovea is the central 2 degrees of vision. The parafovea extends from 2 degrees to 5 degrees. And indeed, and everything beyond the parafovea is the periphery. And indeed, if you see the level of degradation of visual acuity already, you can ask yourself the question if it's possible at all to pick up any useful information from the parafovea. And the answer is yes, and this has been established by using a very specific paradigm. This is called the boundary change paradigm, and it was first used by Keith Rayner in 1975. And the paradigm works as follows. You have here a piece of text. This is one of my favorite quotes from a comedian called Blackadder. Now, the eyes are on the word verbal. The next word, insults, will be in the parafovea. So the question you were asking is, can you already pick up useful information from the parafovea before the eyes actually land on it? Because the moment they land on it, it's in the fovea, obviously. Okay, well, to examine this, what Keith did was he presented sentences like this, but instead of having the word insults in the parafovea, he had complete gobbledygook in it. So a random combination of letters. And then what he did was, when the eyes made a saccade to the target word, he quickly executed a display change, such that by the time the eyes landed on the target word, it was already replaced by the proper word. And then what he did was he compared fixation times on the word insults in the condition when previously it was presented normally, and compared it with the condition where previously it was replaced by gobbledygook. And he found that there was a preview benefit such that you were reading faster if the information was correct. And this benefit was in the order of 20-40 milliseconds. And this shows that you can actually already pick up useful information from the next word. The cool thing about this technique, by the way, is that because you execute it during a saccade when you're functionally blind, people are unaware that you're doing it, that you're changing the display. So they don't notice anything, but we can see from their eye movements, they lost 20-40 milliseconds because they didn't have useful information. So this gives us a little bit of information also about what is so interesting about eye movements and reading. A, because you need that fine-grained visual acuity from the fovea, you will constantly be moving your eyes to what you're processing. But B, as I've also shown, it's not perfect. So for instance, you're already processing information from the next word and so on. Okay, so these are tools that have been used with previous reading research. Let's go back to the question of bilingualism. Well, most of the research that has been done in the past has been done on monolingual research. I'm not talking now about bilingual lexical processing. That's a different field, and there's a lot, they've been at it for a while, obviously. When I'm talking about actually reading, most research there was monolingual, and if you are talking about the available corpus studies, so the ones that process a large amount of material, when we started working on this project, there was the Dundee corpus, this is in English, and the Potsdam corpus, which is in German, and that was about it in 2003, 2004. And also the most influential computational model of eye movement and reading, the easy reader model, has never been implemented for a bilingual context. It's only been implemented for monolinguals back in '98, and actually up until not that many years ago, it was only on English, and then you already have now a couple of languages for which the easy reader model has been adjusted. However, keep in mind, it's always for native speakers. It hasn't been implemented in a bilingual context yet. Now, previous bilingual research, as I already said, were mostly due about visual word recognition. So visual word recognition is a field that is mostly focused about how you process a single word that is presented to you. So not words in context, not reading a single word. And they looked at specific questions there at the word level. And for instance, findings like that is, for instance, you have a frequency effect. The frequency effect is that a word that is highly frequent in a language is processed faster than a word that is low frequent. And they showed, for instance, that in a lexical decision task, you get presented a string of letters on the screen, and you have to say as quickly as possible whether that string constitutes an existing word or not. In that task, you have a frequency effect, so you can say quicker if something is a real word, but it's a high frequent word. Well, this effect tends to be bigger in your second language. That's, for instance, a finding that was done. However, no corpus studies were done when we started on this project, and those studies, not corpus studies, but then regular experiments that looked at sentence levels, was very, very limited. And they still, I would say, when those few studies at that time who looked at bilingualism, so I'd say, for instance, looked at eye movements of people reading in their second language, they were still mostly asking questions at the word level. Like it was whilst reading a sentence, but they still had a question like, what's happening on this specific word? So what happened years ago when I started getting interested in it, of course, if you're in the same department as a big group on bilingualism, you have to read their papers because somebody needs to mark their students, somebody needs to watch their presentations, their colleagues, and so on. So you're gradually in the room, and I always got a little bit annoyed that I said, look, you're saying that the eye movement behavior on this word is due to the properties of that word. Couldn't it just be due to the fact that they're reading in another language? And they always stared to me saying like, I don't get it. And I said like, look, if your word in another language gets skipped less often, is this because there's something special about that word, or is it because people just skip less often in the second language? And then they looked at me and they said, nobody's ever looked at. Nobody looked at global measures of how you read in a second language, like you probably slowed down by how many percentage. They couldn't give me a number. And that's how it started the project, where we said, maybe you should do that. Maybe you should have like people read a substantial body of text, both in their first language or in their second language. And that was the idea that started this project. When you study reading, it's a fantastic technique because it's one of those techniques where you get a really rich source of information that has a really good temporal resolution. So say, for instance, when you look at a specific word, it could be like, for instance, that you make three fixations on it. It allows you to distinguish between an early effect, if it shows up in your first fixation, versus a late effect, if it shows up on the third fixation, or only when people are making regressions back towards it. So it's a very fantastic source of information for pinpointing time course. You can examine multiple dependent variables. So you got like fixation counts, you got durations of fixations, regressions, which is when people go back in the text. You can look at word skipping, which is how often they do not directly look at a word, and so on. And these measures allow you to disentangle early versus late stages of word recognition. One of the biggest advantages is that you're examining a natural process, which is reading. We do not ask people to do something artificial, such as, for instance, give an indication if this is an existing word or not. Name a word out loud as quickly as possible. No, we're asking them just to read stuff on the eye tracker. So they're looking on text on the screen. And in the meantime, their eye movements are being tracked. 30 years ago, that was not a subtle process, because then often the head was fixed. You had a bite bar that you were biting down on something because you were not allowed to move your head with the early eye trackers. Nowadays, we usually use a machine called an LabLing. Most reading researchers use that. And then you can see it displayed here. People are just, you've got like you're resting your head on something. And besides that, you're just reading pieces of words on the screen. This is a very natural way of reading. It's one of the least artificial tasks we have in the lab. Very important, there is no decision component. So if you have, say, for instance, if somebody says lexical decision is reading, I always say like, no, it's more than reading. They read the word and then they have to make a decision. Is this an existing word or not? So you have a decision component. You don't have that in reading. You don't have to interrupt the behavior to make your observations. So that's why it's called online processing task. And just to indicate how different the processes are that we measure when we're comparing eye movement behavior during reading versus lexical decision. A couple of years ago, Victor Kupperman, myself, and some colleagues, we looked at the exact same words that were either processed by lexical decision or naming or during reading, and there was only 17% shared variance between reading and lexical decision. which is incredibly low. All the rest has to do with like decision components, other stuff that's going on. So even though visual word recognition, people quite often say like you're measuring the same, I would actually say like, well, we're obviously measuring something different because we only share 17% variance. And that's why also you see in the field, like everything I say now is definitely true for a couple of years, but where 15 years ago, somebody might take offense with me saying it, not nowadays. Nowadays, they just get an eye tracker and they start doing eye movement research. That's basically what's happening nowadays. Okay, so the goals of the current project, the goals were to construct a corpus of bilingual eye movements, and then we need a control condition as well. So we've got people reading in their first or their second language, and we want to compare it by people reading in their only language. And now, those are difficult to come by, people that read only in one language. So usually we want like undergraduate studies, students. I know in Brazil, you actually even have an illiterate population also that you can still get your hands up. But we are one specifically undergraduate students because we want to match them like on the background, all our participants. So we want undergraduate students. There's only one place where you can find undergraduate students that only speak one language, England and America. All the rest of us have to learn English, right? So that's where you can find them. So then that's why I was also important, because at that moment I already moved to the University of Southampton. My students mostly speak only one language. The ones in Belgium always speak like 2 languages and they're actually educated in 4 languages, right? But if you want that baseline condition of we only do one language, you have to go to England, for instance. The reason why a lot of bilingual research is happening in America is because you've got everything there. You've got pure monolinguals, you've got people who are perfect bilingual Spanish-English, you've got people who are perfect bilingual Spanish-English, but they acquired it early, late, and so on, all combinations you can find, and that's why you see so much bilingual research happening in either the US and then the southern states of the US, and also in the French-speaking bit of Canada is also super, super good for getting your hands on different combinations of bilinguals. Okay, so we're going to create a corpus of eye movements in a natural context. We're going to start with exactly what I was talking about, these global parameters. So when I was annoyed when I saw people present data that I said, wait a minute, couldn't it be that it's just a global behavior that is changing when they're reading in another language, as opposed to the behavior on that specific word? The way you could capture that differences is when you look at global measures. So instead of like the fixation on a single word, you look at the fixations and eye movement across an entire sentence. And I will be looking, I think I got a slide on this, yeah. I will be looking at dependent variables that capture the behavior across a sentence. The first one will be the sentence reading time. So this is the time it takes you to read the entire sentence. I will also looking at the rightward saccade amplitude. So in this example, that's 7 characters. I will be looking at, for instance, do you make longer saccades in your first compared to your second language? I will look at the fixations and I will calculate the average fixation duration and see whether or not it's different in first versus second language. And I will also look at how often people make regressions. You have an example right here, which is when people go back in the text. So normally they read left to right. When they go right to left, back in the text, it's called a regression. So how often do they do that? Those are the measures I'll be looking at. Okay, and the idea is to get sort of a further understanding of language processing in L1 and L2, and indeed a framework for interpreting experimental results. Is the effect you observe indeed due to a manipulated variable on that specific word, or due to global changes in the eye movement patterns when reading in L2? And during this talk, I'll look at 3 data sets. The first is the global measurements, like the ones I've just mentioned. And then I will also look at the study we published where we looked at frequency effects in first and second language. And then very briefly, I will also look at cognate effects in first and second language. Okay, something more about the corpus now itself. Our participants, we ran 14 English monolinguals. And for this, Ushi stayed over a couple of months in Southampton because there she could find educated monolinguals. And then the bilingual corpus was created in Belgium. Belgium is, as most of you will know, is a country that has actually not 2 but 3 languages in it. So we have, say for instance, in the region where Ghent is, which is Flanders, The first language is Dutch. The second language in Belgium is French. And the third language in Belgium is German. We have a small section that is German speaking. However, nowadays, especially in the 21st century, we are so exposed to English that for all Flemish people, their second language is English in terms of proficiency. So we did not work with Dutch and French, we worked with Dutch and English. So there are people like they're unbalanced late bilinguals, and typically you start getting formal education in English at age 14. However, you learn it very fast because they're really related. So across all major languages, Dutch is the language that is most closely related to English. The only exception that is still closer is Frisian, which is spoken in Northern Holland, but that's not counted typically as a major language. So the most related major language is Dutch, and that actually makes it a very good combination of languages to study bilinguals, because that way our stimuli materials aren't too different. This will be more clear in a couple of slides. Okay, keep in mind they're unbalanced, which means that they're definitely stronger in their native language as Flemish than they are in English. However, compared to what most people would consider how they would be categorized, most people would say that they're quite good in English, quite advanced second language speakers. Our participants didn't have any language dysfunctions. They had normal or corrected to normal vision, and they read an entire book. You can see there the book. The book is called The Mysterious Affair at Styles from Agatha Christie. I think everybody will know Agatha Christie probably, right? She's the most read English author. And the book is, in a brief moment, I will explain to you why this book was selected. Have I got a slide on that? No, oh, sorry. In that case, I'll say it here. It was selected for its properties. So it scores on tests that indicate how difficult something is as advanced, but still fairly easy. So if we have like bilingual readers who are not too great, they will still be able to read it. It also has the most normal distribution of high and low frequent words. With that, I mean that if you plot the distribution of how many low and high frequent words they're in, it's closest to normal language, which is not always true of written books. Books tend to be actually a little bit more difficult than for instance, spoken language. And then something very cool about it is that what you see here at the on the cover of the book is a figure called Hercule Poirot. Hercule Poirot in the book is supposedly a Belgian. So this made it sort of funny for us that we were doing this study in Belgium in the book that introduced Hercule Poirot, and sometimes people make fun of Belgium that they don't know any famous Belgians, and they say that Hercule Poirot is the most famous Belgian, which is bullshit, of course, but anyway. Okay, so we've got, we ran university students. The book is actually a rather thin book. They could read it in 4 sessions of an hour and a half. They took as many breaks as they wanted. And the students actually said they really got into it. They quite enjoyed it. They wanted to see how it finished and stuff like that. So it wasn't one of those tasks where our students minded. They were paid quite a bit. I mean, they were paid decently per hour, but because they were doing so many hours, they were actually paid quite a bit, and they really liked it. All the subjects had to do proficiency tests. So there were subjective ratings, asking like, how good are you in a language? When did you start to learn how to do it, and so on. Then we had a couple of more objective measures as well. The lexical is a test in which you are presented with with words, and you have to say whether or not you think this is an existing word or not. A bit like lexical decision. And then the words tend to be rather low frequent, and they're a really good test for your vocabulary size. So they give you an indication of how big is your vocabulary. Do you recognize these low frequent words as words, or do you think they don't exist because you never encountered them? We also had them do a lexical decision and also spelling tests. The Rat and the Gletscher are, I think, the first one is in English and the second one is in Dutch. So we get some spelling proficiency as well. And then finally, during the experiment itself, whenever they finished the chapter, they had to answer multiple choice questions about what they just read, just to make sure they understood what they were reading. Okay, the language skill test, we didn't do them all in one session. So session 1, they had a subjective questionnaire and a lex tale. Session 2, the spelling tests. 3 and 4, lexical decision tests. And what you can see here at the bottom is the data for the monolinguals for the bilinguals in their native language, so that's Dutch, and the bilinguals in their second language, that's English, and then you can see whether or not they're significantly different from each other. Let me first compare I'm looking at the most right column, and those are the comparison between people reading in their first language and people reading in their only language. So we're comparing native speakers here, and what can we see is that there's only one difference here that is significant, which is subjective exposure. The monolinguals are exposed 100% to their only language, where the bilinguals said that they were exposed about 75% to their first language, 25% to their second language. That's of course what you need to find, otherwise you can't do this kind of experiment. If we compare now the values for the bilinguals for their first language compared to their second language, you can see that it's all different. So this is what you would expect because they're more proficient in their first language, they're not balanced bilinguals. So for the Lexdale, they score higher for in their first and the second language. Their spelling is better, their lexical decision is better, their subjective exposure is higher, and then the one thing, when this is very cool, where there's no difference, the comprehension score was the same across all groups, and that's also good because then you can make proper comparisons. Okay, something more about the corpus. I think, no, here actually I do have the information that I was already saying. So this is readability scores, and those give us the information that it's actually a relatively easy text. So we know people who aren't too proficient should be able to read it. I think I already said that. The bilinguals read half of the book in the first language, the other half in the second language, and it was counterbalanced. So some people started reading in the first language, some people started reading in the second language. The monolinguals, of course, read the entire book in their only language. You can see here the comparison. So this here is the original English, and this is the Dutch translation. And what the first thing you can see is that those numbers are very similar, and that is what you get if you compare languages that are very similar. If you were to compare this to other languages, English is quite a dense language. So if you were to translate it into Spanish, you would see a lot more words, a lot more average word length per sentence, and so on. Okay. So what we're first going to be, what I'm going to talk about in the remainder of the talk, now that I've introduced the corpus, is I'll give you a global descriptive analysis of people reading in their first or their second language. And then I'll also compare people reading in their first versus their only language. So people are native speakers then, and they're reading, and we're actually asking the question, does it make a difference if you only know one language or a second language on your first language? And then we'll also be looking at frequency effects, and again we will be comparing first versus second language and first versus only language. And then I'll finish with very quickly saying something about cognate effects. Okay, so we're examining two things: the rank of language, so in other words, first versus second, and also the effect of being a bilingual, where you look at first language and you look at either the person is a bilingual or not. However, this, as you can see here in the comparison, still means that we're constantly comparing two different languages. Now, as I already shown you in the corpus, English and Dutch are, are quite different, but it's still not the same. So what we're going to do is we're going to do something quite extreme. We're going to, within that corpus that is already quite similar, choose sentences that by sheer dumb luck are practically identical in translation. So what we're going to do is select sentences that just by sheer dumb luck have a similar word length, similar number of words. We do not have to match semantics because they're already translations of each other. So that problem we already don't have. And then we're going to match density. So we're going to have the exact same name of words, and we're going to match on average word length within a fifth of a character. This gave us a subset of 210 sentences matched very closely. So you have to imagine, like, this is pretty spectacular, actually. The people are reading a book, either in one language or the other language. These 210 sentences are not artificially created in a psycholinguistic experiment. No, they're natural language. Agatha Christie wrote them down a century ago. By the way, one of the reasons why we also took that book is it's fairly old, and the oldest works of Agatha Christie are in the public domain. They're no longer copyright on it. So we could distribute, say, for instance, also our experimental materials and stuff and such on. We don't have to worry about copyrights. Within that natural language, we selected 210 sentences that are extremely closely matched. So you can see here they have the exact same number of words, sentences, of course, words per sentence. Look how close this is. Characters per sentence, number of content words per sentence, average word frequency, average content word frequency, average word length. These are practically identical sentences, but they're not artificial language created in a lab. They existed just by sheer coincidence. So you have, in terms of natural reading, you can't get better than this, right? People are reading an entire book, and it just happened to be that this sentence is practically identical for everything we know that matters. So those are the ones we are going to be using to compare global reading patterns. And what does it mean reading in your first or your second language? What does it mean reading in your only language versus your first language? Okay, hypotheses. Well, first of all, this will hopefully not come as much of a surprise. We expect costs of reading in your second language. These are not balanced bilinguals, so we expect costs. What is then the pattern that you expect? Well, if you're a beginning reader or a person with reading difficulties, you always show the same pattern, which is lower reading speeds, shorter saccades, longer fixations, and more regression. So that's the pattern that we expect second language compared to first language. Let's call it the reading pattern of beginning readers, but probably we're expecting it to be somewhere in between a beginning reader and an advanced reader, somewhere in between, because they already have language, so they don't have to learn language, they just have to learn a new language. So we're expecting it somewhere to be in between. And there could also be something in there like a compensation mechanism. Keep in mind, you have people here who, of course, are undergraduate students. They go to university, they're well educated, they normally read pretty fast, and then you're asking them to read in a second language and it might slow them down, so they might start skipping stuff. So one of the things we also thought is that they might have something which is called a riskier reading strategy, where you skip stuff more based on partial information, because guess what, you can just read the book if you do that. Something similar we've seen in reading patterns of elderly people in English, where they also seem to skip a little bit more than adolescents. And that's probably due because they have reduced visual acuity in the paraphobia. Their parafoveal processing is less good, so they just skip based on their experience that they know that they can skip certain words. This, for instance, has not been replicated in Chinese, probably because the visual acuity damage in Chinese is too much, so they don't skip more in Chinese, but they do in English. So we thought like maybe something similar could be happening as well in second language. And then to finish the predictions, so we will also be comparing a monolingual with somebody reading in their first language. They have the same proficiency, which means we can test the weaker links hypothesis. The weaker links hypothesis is that the bilingual would be slower. So because of a bigger bilingual lexicon, there would be more lateral inhibition as well, which should have a negative effect on reading speed. And because you use a language less often, because you have two of them, weaker links would mean slower lexical access, slower reading. So this theory actually predict that we would find slower reading in people reading in their first language versus people reading in their only language. All right, finally some results. Now, here we go. For the analysis, we ran linear mixed models. We had a full random structure with, it's just some details, I won't spend too much time on this, with two clusters, subjects and sentences. I already said what our dependent variables will be, and our fixed factors or our predictors are a group, of course. Bilingual L1, bilingual L2, monolingual. How many words were in the sentence? What was the average word length? And what was the average content word frequency? All right. What I will do is I've put everything in graphs, and I'm cherry picking. I'll be completely honest about that. I'm cherry picking based on what I think is most interesting. I won't be focusing on the obvious. I will say what the main effects are. The obvious is that you read slower in your second language than your first language. But I will be focusing on some of the interesting findings, and they're all in graphs. And I will gradually walk you through the graphs. So let's have a look here. On the x-axis here, I have the number of words per sentence. So it means that if you're on the left side of the graph, you've got a short sentence. If you're on the right side of the graph, you've got a long sentence. On the y-axis, I'm plotting sentence reading time. So it's how long it took them to read the sentence. And what you can see here, of course, is that the lines are going up. It takes you longer to read a long sentence. I hope nobody's shocked about that. Okay. Second main effect is the effect of language. You can see that people in their second language, that's the bluish line here, they read slower. No surprises there. What's the interesting thing there? Of course, we've got a lot of power in these analyses because there's a lot of data. There's an interaction there. And the interaction is such that the difference between the two languages is smaller for short sentences than for long sentences. So as a second language learner, you struggle more with a longer sentence, and that is probably due to stuff such as you've got more syntax, say for instance, syntactically more complex sentences, and so on. So probably it's going to hurt you more stuff get added in the difficulty of processing a sentence if you got a long sentence, and that's what we're seeing here. Okay, the next one. I am plotting here average fixation duration on the y-axis. The left graph is people reading in their first language. The right graph is people reading in their second language. Let's first have a look at the first language. On the x-axis, I've got average word length. So this is a sentence with a lot of short words in it. This is a sentence with a lot of long words in it. And what you can see here is that we're talking about average fixation duration, right? So if you've got a long sentence, you'll make more fixations, but how long is it? Well, for your first language, it all doesn't really matter that much. There's not much difference there. Average short word, average long words, you make a fixation that's about 200 milliseconds. Completely different story here for people reading in their second language. What you can see here is two effects. First of all, if you have a sentence with on average longer words, you have longer fixation durations. People are struggling here, probably. So it takes them longer to take in the information and to process the information. And then the second thing I'm plotting here, in this bar here in the colors, is the effect of how many words per sentence there are. And you can see then that the effect is mostly due to long sentence. So if you have a long sentence with really long words, it's really going to hurt you in your second language compared to your first language. And most of the differences here are actually there. Long sentences, long words really hurts you. Those are the syntactically complex sentences, probably. The ones with a lot of content. Okay, next one, I'm plotting here on the y-axis how many fixations you make in a sentence. On the x-axis, I've got the average word length. So again, is it on average short words or long words? First thing you can see is that the fixation counts goes up. That's no big surprise there. So if the average word length of the words in the sentence goes up, you make more fixations. You do so more in your second language than your first language. Again, the blue line is higher. And then you can see an interaction where the difference is bigger if the average word length is small. And this has probably to do with a phenomenon called word skipping. If you're a really good proficient reader, you start skipping stuff. Are people reading in their first language are skipping stuff, our second language people are not. And this is a phenomenon mostly due with the short words. So if you remove those short words, the difference between the two becomes smaller. Okay. Next one, I've got average right per saccade. So if your eyes move into the sentence, how far do you go? And then what we can see here is that the red line is higher than the blue line, or blue-greenish line. What you can see there is that people in their first language make longer saccades. And if it's a long sentence, because on the x-axis here I have number of words per sentence, if it's a long sentence, that effect is even more pronounced. And again, this is probably to do with effects such as word skipping, where if you're an L1 reader, it's a long sentence, you start skipping words as you go along. That phenomenon does not happen to the same extent in the second language. Okay, and I think this is the last one for the comparison between L1 and L2. I haven't said that much about proficiency yet. And proficiency did actually surprisingly little. This is the exception. We have here fixation count per sentence. And we can see here that L2 proficiency causes fewer fixations with better proficiency. So the more proficient readers are actually making fewer fixations. Now, very important to interpret this is that we also measured L1 proficiency, which nobody ever does. So we measured how proficient people they were in their native language. And guess what? Those two are very highly correlated. So the people who are good in their first language tend to be good in the second language. So those factors we could not tear apart. So we're probably talking about the good readers here anyway. but there is an effect of proficiency. Keep in mind, we didn't have any low proficient people in there or any balanced bilingual people in there. So part of the spectrum is missing. We're just looking at the ones in the middle. Okay, so just to wrap up the bit about the global comparisons, I'm going to make two comparisons here. I'm going to compare people reading in the second language versus their first language and people reading in their first language versus their only language. Let's first look at people reading in their second versus their first language. And what you can see is the sentence reading time is longer, not surprising, in your second language. Now, how much is that? It's about 270 milliseconds. It's an increase of just below 20%. So that's the amount we're thinking of, like for a fairly proficient bilingual. You make an extra fixation. The average fixation duration is 25 milliseconds longer. Your saccade length is a character less long, and you skip quite a bit less. That's actually quite a noticeable effect. That is 5% less skipping that is noticeable. There was no difference between in your first or your second language on regressions. That's quite interesting. And this is probably to do with the fact that regressions typically reflect more higher level influences, such as syntactic processing, discourse processing. Probably once you've recognized the word in another language, there's not that much difference between first and second language. So the higher level processes might not be that different. And then, very interesting comparison. We are comparing a monolingual reading in their only language versus a bilingual reading in their first language. And there is absolutely no difference whatsoever. That's why I also didn't show you any graphs of that difference. There's nothing there. It doesn't make any difference if you read a sentence in your first language or in your only language. So that's quite interesting. Okay, to wrap up the first bit, don't worry, the second and the third bit is not that long. To wrap up the first bit, when comparing people reading in their first or their second language, we're seeing more and longer fixations, less skipping, and shorter saccades in second language learning. So we are seeing this child-like behavior, if you like, or beginning reader, or people with reading difficulties of longer fixations, more fixations, less skipping, shorter saccades, but we don't see a difference in regressions. And that's quite interesting in itself. This also reminds of work I was involved with, which you published in 2013. The easy reader model was used to model either adults reading or children reading, and they could model children's behavior completely by changing one parameter, which was the rate of lexical processing. When they turned down that knob, all the other parameters automatically predicted the behavior of a child. So it could be that here as well, we also have only one difference in between, which is reduced lexical rate for people in their second language. We don't see that much else otherwise. And then finally, comparing monolingual and L1 bilingual reading, we didn't see any differences. The weaker links hypothesis would have predicted that we had a difference. We didn't find it. Now, the only thing I would say in their defense, the weaker link hypothesis is mostly working with balanced bilinguals. So for us, remember the usage was 75%, 25%, it wasn't 50-50. So in that sense, the weaker links would probably predict a smaller effect for our group, but we didn't find anything. And then finally, we're on the comprehension side. A lot of the findings of the weaker links, evidence for it was on the production side. So that could also make a difference. Right, I'm on the second of three studies, and let me look at my time. Don't worry, they're each time only a couple of slides. Right, frequency effects. High frequent words are processed faster than low frequent words. And these are one of the most replicated effects in psycholinguistics. They're super robust. Basically, if we've got frequency manipulation and if we don't find it, we assume there's something wrong with how you run the experiment, as opposed to the effect, because we always find it. How about in bilingualism? Well, in isolation, so using tasks such as, for instance, lexical decision, the frequency effect tends to be larger in the second language. Now, this in itself already makes sense because the frequency effect is mostly due to differences between low frequent and very low frequent words. If you read in a second language, you will have more low frequent words that you haven't encountered much yet, which will create a bigger frequency effect. How about in your only language versus first language? Again, the weaker links hypothesis says you're less exposed to it. So it would be almost like a second language in the sense that also there would predict a bigger frequency effect in a bilingual's first language than in a monolingual. So let's see if that is true, actually. Okay, let me walk you through this slide. This was not done on the restricted set of those 210 sentences. This is on all the content words in the corpus. There are 30,000 content words in there, so this is a huge data set. Right, let me walk you through this. I have here 1, 2, 3, 4, 5, 6 graphs. These ones are ordered in terms of L1 proficiency. These are, if you like, the worst readers. These are the best readers. L1 proficiency is so proficiency in their first language. In this case, it's first or only language. I'm plotting single fixation duration. And here within these graphs, I'm plotting word frequency. This is the lowest frequent word, and this is the highest frequent word. So let's first look at the main effects. First, you can see an effect of frequency. All these lines are going down, which means that the low frequent word gets processed slower than the high frequent word. This is the frequency effect. The second effect is an effect of proficiency. As proficiency goes up, you see these lines gradually going down. They're faster. The most proficient readers are the fastest. And then the interesting bit, which is the interaction. What you can see here is that the frequency effect is getting smaller. So the most proficient readers have the smallest frequency effect, but it's not just randomly on both sides. It's very specifically something is happening. It's the response time to the low frequent words. So what you can see here, and these are the low frequent words, it is the more proficient you are, the faster you are to the low frequent words. The difference isn't that pronounced for the high frequent words. So as you are getting more proficient, you get a smaller frequency effect, but it's due to faster response to the low frequent words. Now compare directly the frequency effect in the first versus the second language. We replicate what has been found in single word recognition tasks, which is that the frequency effect is bigger in the second language. So we found a 17 millisecond effect in first language. We found a 26 millisecond effect in second language. Again, you can see, of course, that people are slower reading in their second language. And you can also, if you look very closely, you can actually see that also the effect is mostly due again due to the low frequent words. That's where most of the effect is. Last slide for this one. I'm comparing the frequency effect in L1 and L2. And you might wonder, like, where is the L1 and the L2? There was no difference there once you plot it like that. What I'm plotting here is on the x-axis again, L1 proficiency. And then here I have for each graph word frequency. And I'm seeing the exact same phenomenon as I did when I compared the first language with the only language. So what's happening here is that our results are being predicted by L1 frequency, not L2 frequency, both in first and second language. However, keep in mind, they were very related. And it could be that our L1 proficiency picks up a bit of the L2 proficiency because they're correlated, and also that L1 actually picks up more than that. That L1 proficiency is probably people who are just either better at language, or it could be that they just have a bigger vocabulary and so on. So it could be more of a general aptitude, and that we see this. We can't compare this to other studies because most studies never bother looking at both L1 and L2 proficiency in the same study. Okay, so to wrap up frequency effects, for the native speakers, so we have like monolinguals versus the first language as a bilingual. We found that higher proficiency leads to a smaller frequency effect. This is mostly due to speeding up of the low frequent items. This is compatible with an account which is called the lexical entrenchment account, which in a nutshell says there are no qualitative difference between these groups of people. It's only quantitative, it's only exposure. So there's no effect of being a bilingual, not on reading times, but also not on frequency effects. Throughout the entire experiment, we never found anything. And then comparing L1 and L2, we found a bigger frequency effect in the second language. And then surprisingly, there was an interaction, but not with L2 proficiency, but with L1 proficiency. And probably our L1 proficiency, first of all, it correlates quite a bit with L2, but also picks up more than just L1 proficiency. It could be general reading skill, language aptitude, and so on. Our results are again a bit different from people who looked into the weaker link hypothesis. For a direct comparison, we also have to point out that most people use subjective norms subjective proficiency measures. So you ask somebody to rate how good they are in a language. We used objective ones. We measured vocabulary size and lexical decision, so that could also be a difference. Okay, I've got 2-3 slides, my last slides, on the cognate effect. Remember, a cognate is a word that has the same meaning, but is typically written slightly different or identical. So we're going to compare both identical cognates, such as, for instance, the word film is film in Dutch, written the exact same meaning. And non-identical cognates, so the words paradijs and paradise in English, those are cognates, they mean the exact, but as you can see, they're written slightly different. Previous findings show that cognate effects are stronger in L2, so you have a bigger benefit in your second language if the word also exists in your third language than the other way around, but it also exists. The literature where it was when we ran the study said that the cognate effect depends on sentence constraints. So if you have a very constraining sentence, so a specific word is very predictable in the sentence, say, the baker rushed the wedding cake to the reception, the word cake is very predictable in that sentence, you won't find a cognate effect that gets washed away with the predictability effect. And then those few studies, there's only, at that moment, 2 L1 studies, sentence studies done, gave inconsistent results. And then also those studies that looked at sentence reading, there's also only one that looks at stories or books, and only that one was done in L2 and showed facilitation. So limited evidence for what we are doing. Okay. We took the GECO corpus, we took all nouns that weren't sentence initial or final. For Dutch, that was 7,988, of which 1,776 were unique. For English, slightly fewer. Then we did a manual check and identified the identical cognates, and we had 548 in the L1 and 675 in the L2. And then of which were unique, 94 in Dutch, 142 in English. So those are the identical ones. For all the other ones that are not identical, we calculated what's called the Levenstein distance, and that's just a measurement that indicates how similar 2 strings of letters are. Okay, so what are the results? I'll go straight to it. First of all, I'm mapping the cognate effects just to show you that we found it. And what I'm plotting is first fixation duration. What you can see here is first the main effect of reading in first versus second language. Second language is slower. And then you can see an effect, and it's small, right? The only reason why we got a significance is because we got so much statistical power. You can see is that as orthographic overlap gets bigger, i.e. the words become more similar, you do get a shorter fixation duration, first fixation duration. In both languages, there was no interaction. This is a big graph. Let me just quickly say what is here. These are the means for all the measurements we looked at. This is the effect of identical status. This is the effect of orthographic overlap. So this is how similar they are. And here we look, is there something special for the ones that are identical? To make a very long story very short, the effect of orthographic overlap is super small. We're talking about 2 to 3 milliseconds. It's like almost 2 milliseconds in first language, almost 3 milliseconds in second language, only in first fixation duration and in nothing else. Is there an effect of identical cognate status on top of that? Almost never, only in second language in the latest measure, total reading times and GOPOS. So there's a very late thing going on where if something is identical, you tend to make slightly less regressions then. And it's only in second language. So very limited evidence for something that is happening on top of similarity. All right, this is my last slide. I have shown you 3 studies, one on global measures, one on frequency effects, one on cognates. If you want to read more, we also published a paper on inter- and cross-lingual neighbourhood effects. Those are words that are very similar to each other, but not cognates. And then my colleagues continue to work on these data sets. They published a paper in 2017 on age of acquisition effects. And in 2019, a work on reading of short paragraphs versus books. Does it make a difference if you're actually in a narrative? And then finally, if you want to contribute to it yourself, the entire corpus you can download on this address. It is available online. We've written a behavior research methods instrument paper on it that completely documents what we did, how you can download it, what the different measures are. So especially now in these days, ladies and gentlemen, where we have a pandemic and it's difficult to get people to come into the lab, this is a really high quality data set and it's available for everybody to start working on it. Okay, that's it.
All right. Thank you very much for this talk, Denis. It was really, really interesting. We have received a lot of questions. So we've had a lot of people viewing the talk. I was checking out YouTube while you were talking. Yeah. So we have a lot of people watching. It would have been a full room if you were actually in Brazil. So I'm very happy about everyone who came. And yeah, we have a couple of questions here, so I'll go through them. I don't know how much time we have, how much time you have. I mean, I'm free to keep going.
Yeah, same here. I've got some.
Okay, so I will just keep giving you questions until I'm told to stop. So okay. And then some of them are quite difficult for me to not answer them myself, but because they are
we can answer them together if need be, right, Bernie?
Okay, but you're the presenter, you have priority. Okay, so first one, and I have to apologize for the pronunciation of the names, is by Pietra Casol Higati. Professor, could we say that people mostly skim read when they read on the web? What aspects makes that different from reading a book, for example?
Oh, that's a question that would have gone very well with another talk I've given in Fortaleza. So in a nutshell, right? So this is I supervised a PhD from a student called Gemma Fitzsimmons, who did a lot of stuff on reading for comprehension versus skim reading, and then on top of it, what does it mean within the context of the reading on the web? To make a long story short, the reading on the web is a very interesting special case because you've got these hyperlinks. And so what we found was that when people skim read on the web, they first use these hyperlinks as anchor points. And what we saw also is that people lexically process words different during skim reading, but not the hyperlinks. So say, for instance, you have a healthy frequency effect during reading for comprehension. If the same text is used during skim reading, this frequency effect is seriously reduced, but not for the hyperlinks, showing that you process this completely. And this gives us an indication that when you start reading on the web, you read the hyperlinks, and it's because they give you an indication both what is the global content of that website, and also where is the most important information, what's worthwhile examining further.
Okay, yeah, and it is a really interesting question what people do on the web. It's something that advertisers would pay a lot of money for to know, like how much do people read, how much do they skim.
Yeah. Can we make people look at your advertisement? There's money in that. Yeah.
Exactly. So I'm advised that we have 30 minutes to for questions. We'll see how far we go. I'll start with the ones that were asked first, but then later I might have to skip ones, and the ones that were asked like very recently, I might not get to all of them. Okay, the next one, also interesting general one by Luisa Carvalho. Professor, do you think that words that share phonological information but are written with different scripts writing systems will also be processed faster?
Yeah. We know that you do phonological processing, and we know that you have we know that you have an advantage if the phonological processing is, for instance, similar. Have people done this already? Where they so there's one Altariba study where she offered words. Say, for instance, people are reading, and then what she did was, instead of give them the word money, she gave dinero as a preview. And then what she found was that there was, I think there was an advantage, but she didn't look at phonology. So based on the literature, you would say yes. However, keep in mind, within the same language. So for instance, if you examine this question within the same language, you would have, for instance, a homophone in the preview, where you would have like, instead of cent, C-E-N-T, you would have cent, S-E-N-T, which is a homophone. You would have that in the preview, and then when the eyes actually land on it, you can see, oh, they read faster, they process the phonological information. That effect is not very big, so you expect it to be smaller if you also have to go from one language to the other. So it could be that it's there, but you might have a lot of you need a lot of statistical power to have it significant. So my prediction is yes, but it's a small, numerically small effect.
In terms of the different writing systems, there's this experiment that I've been wanting to do for a long time, but I can't because I don't have access to Japanese readers. So you know that Japanese has at least 3 different ways of writing the same word: hiragana, katakana, and kanji. So it would, I'm not sure if someone has done, no, in reading, no one has done that. I'm not sure if anyone's done it in sort of priming, but like the same, like does a preview of the same word in one writing system. How does that compare to a preview in the same writing system that it's in?
GECO at a certain moment collaborated with people in Japan, but it was only one paper because it wasn't, well, it wasn't an easy collaboration. And there they did stuff on like, because at a certain moment, I can't remember which one, somewhere halfway in the word, you switch from one to the other writing. And because they're visually a little bit distinctive, they give you cues about where the word endings are. And as a result, Japanese seems to show the eye movement pattern you expect more for a spaced language, even though it's unspaced, because they pick up the differences between the scripture and they target their word accordingly. Yes, that's such a fantastic language to play with. Right?
It is really interesting because you have they actually use the kanji to indicate sort of where's the root morpheme, and then the when they inflect, for example, a word, they use the hiragana for that. So it is super interesting. So okay, so for the answer to the question, looking for Yuka Hiona's research, looking for that collaboration would probably answer that, or go some way towards answering that question. Okay, and then we have another question by Erika. No, wait, sorry, that was Luisa. Then we have 2 questions by Erika Rodriguez. Are there eye-tracking studies that investigate the effective level of proficiency in reading in a second language? Well, she asked that before you reported that, so that's great. Would you expect differences regarding the reading of function words?
Yes. So function words are always a bit interesting because people almost don't want to land on them. So what you get is these absurdly high skipping rates. And then also it's a little bit difficult to compare because function words, languages are quite different in terms of function words. So some languages don't have them, full stop. In other ones, they're like, they don't carry any information, like English is pretty meaningless, right? The function word. Whereas, for instance, in Dutch, male and female carry one function word, neuter carries the other one. In French, male and female is different, le, la. So you get like, and it's also marked for like whether or not it's singular or plural. In certain languages, you will have case marking of function words. I would say the more information is contained within the function word, I would predict the more it behaves like a content word. And in certain languages, like in English, if they do land on it, they want to get the hell out of there and quickly go someplace else. So it's really different.
Yeah, I mean, I don't think it has ever been formally tested. So, for example, German has a lot of information in the articles, if you think about it.
Exactly, They have
3 genders, case marking, strong and weak inflection, and all that. So in theory, there should be less, for example, skipping of function words, but no one's tested it. So this is something to do in the future. Yeah. And then one more question from Erika is, would you expect different results if the task was, for example, to produce a summary of the book instead of just reading it?
Yeah, I would. Although that one would actually be fairly. That one would still be. I think I would expect them to do still fairly thorough reading, but I wouldn't massive task effects. Right? Like what we said about the skim reading versus reading for comprehension. Like a certain moment during that PhD of skim reading, we never did it, but we wanted to look at like, oh, you want to select the movie. And you've got like movie reviews and what you pick up, and probably you only read like 2 lines and we go like, oh, it's science fiction, I don't like science fiction, or oh, I hate that actor. And then you would see that kind of behavior. So yeah, I think the task difference would be huge. Yeah, huge.
Yeah. So so if you're interested in research on task effects, again, Jukka Hiona and Johanna Kakinen, both from University of Turku in Finland, have done some really interesting studies on that. Okay, so then the next few things I think were comments on the proficiency question. Okay, we have one question by Liana Gadelia. Professor Drieghe, could homographs be named slower than control words in a translation study experiment?
This is in a translation study experiment.
So, well, it was.
You would predict it probably, yeah. I'm not sure if somebody's done that in a translation study. Translation studies is you've got translation studies is a field where a lot of research is going on, but it doesn't interact that much with psycholinguistics often. Not the bit that I'm familiar with. Whereas it would be super interesting if those fields were collaborate more.
Yeah, it is interesting. This talk series is actually interesting because we have people from both sides. So so it's really.
Translation has a practical component in it because we need to do it, but also from a theoretical point, it's just super interesting to see how people switch between it and stuff like that. Yeah.
It's a very interesting task. It's related to what we usually study because it involves, for example, reading and listening, but it involves so much more. Yeah. And it involves decision, but a decision that's much more complex than lexical decision. Okay. Absolutely. Yeah. Okay, so then we had a question, how do you measure L1 proficiency? But you said that already. Okay, then we have a question from Professor Mota. So Denis, could you talk a bit about the implications of a corpus like this for education? So how could you use this?
Oh, that's a good question. So first of all, the reason why we also took the book of Hercule Poirot was because it's translated in an incredible amount of languages. So if people want to redo the experiment in different languages or in different educational settings, like for instance, different proficiency of readers, it's possible to do it. So up to a certain extent, I would say like it's an ongoing project. From an educational point of view, oh, that's interesting. I think the interesting bit would be if you really start comparing people of different proficiencies. Now, if you do that, you enter the world of individual differences. And that is a super interesting field, but it comes with a huge cost, which is that you need to run a really large amount of participants. So I don't know if you've seen if you remember the numbers where we were at like 14 monolinguals and 19 bilinguals, and we have an incredible amount of power within those people, but we don't have much power for comparing those people. Sure. But that we would really need 100. And then, for instance, we could say, look at differences, and then it would become interesting. Like, for instance, here's a classic one, like so at a certain moment, we didn't get it funded, not yet, but I was looking into heritage language. And heritage language is the language that your parents speak at home, but you're educated in another language. So say, for instance, I live in Southampton. There's a big community of Polish people here. So we have people who grew up as a bilingual. One is their heritage language, another one is their dominant language. And then we would have wanted to look at, for instance, like how good are they still in their heritage language, and try to predict it based on individual differences, such as did their parents read to them in Polish? they often speak still Polish, but do they actually read books in it? Do they follow Polish media and stuff like that? And then if you can predict them how well they are in reading, then we are in the educational field, right? Then we can really talk like, okay, this is what you need to do, say, for instance, to prevent attrition of a language. Once you're in a dominant other language, oh, they need to keep reading, or like, oh, this, for instance, some people have thought that the childhood stories just before bed, that those are super good if you want to like keep a language alive in your child. So I would say, if you want to do that, you need to build further on what we did with it. I don't think our data are good enough for it. That's what I think. We would, from an educational point of view, I would also like ask other questions of our participants, such as, for instance, background, educational background. Yeah.
But so I was just thinking, if you do build on it, if you have more, if you get more data, I mean, at some point, you could even think of it as being the fundament of developing a sort of a reading test, a reading proficiency test. Yeah. So basically, we give you a paragraph from the Mysterious Affair at Styles, and then at the end of it, based on your eye movements,
that's absolutely right. So at the moment, we have comprehension tests that do something similar, but they never do eye movements. And this could like be the beginning of like a norm based on eye movements where. Yeah,
I'm thinking also machine learning could maybe help with that, because this is the kind of classification task that those models do.
And
okay.
Also, what we've got is that eye trackers are getting cheaper and better, right? So at the moment for reading, we are looking at iLink 1000s, which aren't cheap material, but they can tell us within half a millisecond and which part of a letter you're looking at. The cameras that we're using as we are speaking now in our webcams are getting better and better. Like give it another 10, 20 years, and they do give another 10 years, they do eye movements on the spot, right? I mean, they can already use them for like saying which part of the screen you're looking at, but of course not which word you're looking at. But that's the future. The future will be cheap eye tracking, just basically using your webcam.
Yeah, I would say even 5 years. I mean, it's,
could be.
With virtual reality, the nice thing is we're getting better and better cameras built into devices. Yeah. So let's hope for that. Okay, let's move on to the next question by Daniele Santos Vicentine. Hi, Daniele. Professor Drieghe, was there a pattern of skipping words in L1 since they made long saccades?
Yeah, there's quite a bit more skipping in. Wait, let me just quickly see if I've got that on. Yeah, let me take over the screen just for a second.
Sure.
So these are two published data sets. This is on kids, this is on adults, and I've got the slide ready if I need to make if somebody asks about the comparison. But at the bottom here is our data, and here you have the skipping percentage. And what you can see here is first versus second language skipping. So we've got about 5%. You can see no difference as constantly, right? No difference between first language or only language. But there is quite a difference, and 5% is that's noticeable. That's noticeable. They skip a bit less.
Okay, great. All right. Next question by Pedro Ricardo Bin. Dr. Drieghe, what is the importance of a corpus as corpus like GECO? To research on reading in a first and second language. Also, regarding the open science movement, how important is it to have an open access data set to improve and replicate findings?
Yeah. Oh, I would say this is the way to go, right? So it's been the data set has been online now for a couple of years, and I know people who have run simulations in it, and it's fantastic, right? I mean the effort was gigantic. So what we did was, which is what most people do when you do a project like that, is you create the corpus, you first publish the first 3 papers by yourself. You don't share the corpus on day 1, right? Otherwise, if for instance, Ushi first needed to get her papers in her PhD, and then the last paper was the behavior research method paper where we made the corpus available for everybody. The one thing you don't want to do is like make the corpus available, break your back doing it, and then somebody quickly publishes all the main findings. But it's very important that it's out there, and it's important also within open science that people can build on it now, and that is fantastic. So what is the important for a field like that? I think the biggest importance is that, like what I said, well, the people were making quite statements about what is happening at the word level, and they never looked at what happened at the level of the sentence. Like now we can say like, oh, they skip 5% less anyway in second language for intermediate proficiency. We've got a number there. So anybody who says like interprets their findings or like they skip 5% less because I use these specific words, you go like, no, they just do that overall.
Mm-hmm. Yeah, it's very. I just wanted to say, I think Tim Slattery has mentioned that he's using the corpus. He's looking at that for the return sweep. So Tim gave a talk in the series a few weeks back.
Tim contacted me to see if I have the data on return sweeps, but I had to direct him to Nicolas Dirks, who will have the actual. So what is online is the if you know iLink outputs, is the interest area file.
I see. Yeah.
What you need is the fixation report. So I contacted him to the person who probably still has that.
Well, that is also the neat thing of having things online and being available. So you can always, even if the information that you need isn't in the data set that's online, you can always go back to the authors and ask for it, right? It's just in 10 years or 15 years, maybe maybe you won't. Maybe in the old days. Like if you had done the experiment in 95 or something, 15 years later or 25 years later, you wouldn't have the data anymore. But now the data are online and available, and they will stay there as long as the OSF, for example, as long as they have funding, which I hope will.
I can't see them running up. Yeah, so I'm an associate editor for behavior research methods, and there it will be, unless there's a reason. Unless you have a reason why it's not online, it's a requirement for publication for behavior research methods.
Yeah, that makes.
There has to be like a copyright issue or privacy issues. Otherwise, it will be.
Yeah, makes a lot of sense. Okay, we have a question from Pamela Toasi, who managed to I think watch part of the talk at least, despite the internet issues that you had. So she's asking, Denis, how is the cognate effect affected by pairs of words that differ in their frequency in the L1 and L2? So, for example, a word that has a high frequency in the L2, but low frequency in the L1, but very similar.
Yeah. Good question. I don't think. So in the results I showed you, I don't think there was actually differences between the high and the low frequent ones. Not for cognates. We found something for neighbourhood effects, which is quite a complex story. So unless somebody's got specific questions on it, I wouldn't go into it. But I think for that one, let me double check. I've got the paper here in front of me. Let me just quickly see if there was a significant difference in frequency. No, there was no difference with this. So the cognate effects seem to be at that base same as for the high and the low frequent. Keep in mind, as you remember when you saw the data, it's a very small cognate effect. So and this is classic, is that effects that are, say, for instance, well established in lexical decision, when you look at them in the wild, if you like, so during natural reading, you see that the effect sizes go a lot smaller. So it could be that, for instance, if you were to have a bigger effect, say in lexical decision, that you can find that effect, but here we didn't find it.
Okay, one last question by Pietra Casol-Higati. Professor, what could have influenced the weak cognate effect in the last study?
I think a little bit the task. So that's what I've already said. Like, so they tend to be smaller. That's A, and B is also that, especially for the non-identical cognates, there could be some effects of the fact that you are reading in a language. So you are reading in you're reading in English, for instance. You expect English words. The fact that that word also exists in a rather similar version in Dutch might have a bigger effect if it's just presented out of context, or definitely in a context where, for instance, both languages are, for instance, possible. Then that context that constantly says to you, oh, you're reading in English, you're reading in English, you're reading in English. The research shows that it doesn't disappear, the cognate effect, but it does seem to be a bit reduced, yeah. But what we don't know is it because they're reading in one language, or is it because they're just reading large amounts of text? Because both of them, we sort of assume that they would reduce the cognate effect. Yeah.
Mm-hmm. Yeah. So you just get used to. Well, yeah, it could be both. You just get used to. Oh, this is English, 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 and then you don't have to. Yeah. Whereas if you just get a new sentence, and especially if you get things mixed between languages, then who knows? That might be something. Okay, so I think we'll wrap it up now. Again, thank you. And would you like to say a final word to the audience before we say goodbye?
Oh, no, I don't. I just I wish you all well. I hope that once we have this goddamn awful pandemic behind us, I will be giving these talks again live in Brazil. As opposed to online. That's my wish for everybody, that we can travel again.
All right, thank you so much, and also from me, thank you very much to everyone who listened and who joined up. To me too, these talks are a really great source of academic interaction and being and getting new ideas during this time when we can't see each other in person. And I think that also for all the students who join in, it's really great to see people from lots of different areas or lots of different places in the world give these talks. I really always enjoy seeing the amazing questions and everything. So it has been a really great experience, both when I gave my talk and now today. And yes, with that. So I hope everyone has a great rest of your day, and I hope to see you soon in either in person or in another talk, or who knows, at a virtual conference. All right, goodbye then. Bye-bye.
Bye.